Hey guys, so in the next couple of units, we're going to learn about compounds. A compound is formed when atoms of different elements, at least two different elements, bond together, form a chemical bond with each other. And over the next couple of units, we're going to learn about two different types of compounds. We're going to learn about ionic compounds first, and then later on we'll learn about covalent compounds. The two different kinds of compounds, they form for different reasons, but the reasons are similar. And we'll get into that in a few minutes here. Today, we're going to talk about ions, how and why ions form, how we name ions, and how we write symbols for ions. And then in the next lesson after this, we'll talk about ionic compounds and how they form and how we name them and so forth. So the target for today is to be able to describe the formation of ions. Okay, kind of the reason that compounds form whichever type they are is has to do with their electrons. Okay, we've learned that atoms generally have the same number of electrons as protons. So if I'm talking about aluminum, I see 13 is the atomic number, and I say it's got 13 protons and it's got 13 electrons. But atoms actually usually like to have the same number of electrons as the noble gases. Okay, so they will try to get the same number of electrons. They'll either gain, lose, or share electrons to try to get the same number as the closest noble gas. So when they either gain or lose electrons, they form what's called an ion. An ion is an atom that's got the wrong number of electrons. When they share electrons, they form what's called a covalent compound, and that'll be the next type of compound that we talk about later on. When they form ions, the ions have an electrical charge and stick together, and that's the kind that we're going to talk about first here. So let's talk a little bit about gaining and losing electrons. If you take a look at some of the elements that are close to the noble gases, let's talk about the halogens for a minute here. Let's say maybe we're talking about chlorine. Okay. Chlorine has 17 electrons. I asked myself, which noble gas is closest to chlorine? And well, argon, number 18, is right next to it. Okay, so if chlorine had one extra electron, it would be like argon. So what a chlorine atom is going to tend to do is it's going to tend to gain an extra electron so that it can be like argon. It's still a chlorine atom. It's still got 17 protons, but now it's got 18 electrons. So you can see a chlorine, and really any of the halogen atoms, are going to gain one electron to become like their nearest noble gas. Okay. Now electrons have a negative charge. So if you gain a negative charge, you become negative. So the halogens, each one of them, fluorine will gain one electron to become like neon. Chlorine will gain one electron to become like argon. Bromine will gain one electron to become like krypton. Iodine will gain one electron to become like xenon, and so forth, right? So each of them will gain one electron to become like a noble gas. And when you gain one electron, we say that you have a charge of -1. Consider over here on the other side of the periodic table. Let's say we were talking about your alkali metals over here. Okay, the alkali metals, how far are they away from the noble gases? They look really far away because they're on the opposite side of the table, but they're actually very close. Let's take, for example, sodium. Sodium's number 11. Right, you can see sodium right here, it's number 11. Which noble gas is closest to number 11? And you can see over here, neon is number 10. 10 is close to 11, right? So how would sodium become like neon? How do you go from 11 to 10? Well, you have to lose one. So the sodium atom, and really any of the alkali metals, they're going to lose one electron to become like their nearest noble gas. Okay? If you're losing a negative, you're going to become positive. So all of these alkali metals are going to end up with a charge of +1. So you can see lithium is going to lose 1 to become like helium. Sodium will lose 1 to become like neon. Potassium will lose 1 to become like argon, and so forth. Right? Each one of the alkali metals will lose 1 electron, so that they'll end up with a charge of positive 1. Think about the column next to them, the alkaline earth metals, starting with beryllium and magnesium and calcium and so forth. How far away from the noble gases are they? Well, let's think about maybe calcium as an example. Calcium is number 20. Which noble gas is closest to number 20? That would be number 18, argon, again, right? So how do you get from 20 to 18? Well, you've got to lose 2. So again, they're losing electrons, so they're going to end up being positive, but now this one's losing 2 electrons. So we're going to say its charge is positive 2. All right, so real quick check there. Think about for a minute, pause the video, answer this question, and then see if you were right, okay? Think about sulfur, number 16. Which noble gas is it closest to? How many electrons will it gain or lose? And what will be its charge? Pause the video, figure that out, and then resume and see if you were right. All right, hopefully you got an answer there. Sulfur, it's number 16. It's closest to argon, number 18. So how do you get from 16 to 18? You need to gain 2 electrons. If you're gaining electrons, you're going to be a negative. Okay, so the sulfur ion is going to have a charge of negative 2. Okay, for a lot of the elements on the periodic table, it's really figuring out the charge of their ions is really just as simple as looking at what column they're in. All of the alkali metals are going to form ions that are positive 1 because they're just 1 away from those noble gases. All of the alkaline earth metals will be positive 2 because they're just 2 away from those noble gases. The noble gases don't form ions, so you might say their charge is 0. The halogens are all they're just 1 electron away from the noble gases, so they're all gonna form ions that are negative 1. The chalcogens are gonna end up being negative 2, the pnictogens will be negative 3. And then the carbon group here, the column that starts with carbon, it can be positive 4 or negative 4. We're not really gonna get too much into ions for the carbon group. They generally form the other kind of compounds, and we'll talk more about that later. And then the group here that's got boron and aluminum, some of those right here end up forming ions that are positive 3. So you can see positive 1, positive 2, positive 3, 0, negative 1, negative 2, negative 3, and then these could be either positive 4 or negative 4. You might say, I'm sure most of you are saying, what about the transition metals? Well, the transition metals are not so easy to predict what kind of charge that their ions are going to have. Some of the transition metals can have more than 1 ion. Copper, for example, can have an ion that's either positive 1 or positive 2. Iron, for example, can be either positive 2 or positive 3. Some of them form multiple different ions, 3 or 4 different kinds of ions. And some of them form ions as high as positive 7. So, I mean, the transition metals are not quite as simple to figure out what their charge is going to be. If you need to know what it is, I'll tell you. I'm not going to ask you to predict for them. We will talk about how to name them because their naming is a little bit different from the more normal ions. And over here in the P block, there are a few elements that behave more like the transition metals, particularly like tin and lead. Tin and lead can each have several different ions. They don't especially follow the pattern in their family there. So they can have, several different ions. One thing you might notice is that all of the elements that are metals form positive ions. We have a special name for positive ions. We call them cations. And you might notice the elements that are nonmetals form negative ions, and the ones that are negative we call anions. So the positives are cations and the negatives are anions. And I'm sure everybody's saying, I'm never going to remember which is which. And that's where we have this corny meme here. How do you remember the difference between cations and anions? Cations are positive. It's corny, but you'll remember it. There are also some ions that form from groups of atoms, and you should see a chart up here. These ions that form from groups of atoms are called polyatomic ions. We'll talk more about polyatomic ions later. Basically, they're an ion that's formed from a group of atoms. Most of them are anions, they're negative ions, but there is one notable cation, so ammonium. I am not going to ask you to memorize a list of polyatomic ions, but whenever we work with the polyatomic ions, I will give you a chart of them where you can see their name and their formulas, and you'll see their charge. So you'll know what they are. You won't have to memorize them at all. All right, let's talk for a minute about the names of ions. Let's talk about simple cations first. Let's say we're talking about a cation from the alkali metals or the alkaline earth metals, or even over here around boron or aluminum. An ion that can only have one charge, a very simple one. To name these ions, okay, really complex here. To name these ions, you take the name of the element and you put the word ion after it. So if I'm talking about an ion that forms from a calcium atom, the name of that ion is calcium ion. Really tough, right? Let's talk about the anions for a minute. Okay, the negative ones that form from the nonmetals. It's a little bit more complex, but it's still really very easy. For the negative ions, all you really have to do to name the ion is you change the end of the word of the element to ide, I-D-E. So if I'm talking about nitrogen, for example, the atom is called nitrogen, but the ion is called nitride. You change the end of the word to ide. If we're talking about chlorine, you change the end of the word to ide. So instead of chlorine, it's chloride. So any of the negative ones, you just change the end of the word to ide. The positive ones, the simple positive ones over here, you just add the word ion at the end. Pretty simple. Now, the ones in the transition metals and the ones after the transition metals over here that can form more than one ion, it's a little bit more complex, okay? Still not really that complex. What you do to name these ions is you name the element. Let's say we're talking about a copper ion. And let's say it's a copper ion that has a charge of +2. Okay. What we do is we put the name of the element, which is copper, and then in parentheses, we put a Roman numeral to indicate what the charge is. And so since this copper ion that we're talking about has a charge of +2, I'll put copper, and then parentheses, Roman numeral 2, and then the word ion. So the name of that, the way we would say that is we would call it copper 2 ion. Similarly, say an iron ion with the charge of +3, I would put iron, parentheses, Roman numeral 3, and then the word ion. Pretty simple. For the polyatomic ions, there is a naming scheme. We're not going to get into the whole naming scheme about how we figure out what the end of the word is. There are several. So we're not going to get into that. We'll have a list of polyatomic ions and you'll see what their name is. Okay, real quick check for understanding here. Answer my questions, pause the video, answer my questions, and then resume and see if you are right. Tell me, what is the name of an ion that forms from a magnesium atom? What is the name of an ion that forms from a sulfur atom? And what is the name of a nickel ion with the charge of +2? Pause the video, answer those questions, and then resume and see if you're right. Okay, the magnesium ion is called magnesium ion. The sulfur ion is called sulfide. And the nickel ion that had a charge of +2 is nickel 2 ion. Pretty simple? Okay, last thing to talk about, we need to be able to understand the symbols for ions as well. The symbols for elements, you know, like lithium is Li, simple enough, right? But when they're ions, we add the charge onto there. So let's say we're talking about a simple one like calcium. If you see where calcium is, it's going to form an ion that is +2. So how do we write the symbol for a calcium ion? Well, what we're going to do is we're going to write Ca for calcium, and then in the upper right corner there, we're going to write the charge. And since the charge, see, it's in the alkali earth metals, it's going to end up with a charge of +2. We're going to write up there 2 plus. And it'll be the same for any of the other ones. If it's negative or if it's positive, you're just going to put the charge in the corner there. A few odd things you've probably noticed already here about the way that we write these. Okay. First thing, usually when you write a number, if it's a positive number, you don't need to put the plus sign, but when it's an electric charge like this, we always write the plus sign. So whether it's positive or negative, you always write the sign. Second weird thing is we put the number before the sign. Don't ask me why we do this, I have no idea. But you notice I didn't write +2, I wrote 2 positive. And we also often say it that way. So I would say Ca2 positive. Third weird thing is that if the charge is +1 or -1, we just write plus or minus. We don't write the 1. I don't know, I think like in algebra, you don't write 1x, you just write x, right? And it's the same here. We don't write +1 or 1 positive, we just write positive. Same thing with negative. So if the charge is just 1, positive or negative, you just write positive or negative. So for example, the sodium ion, Na, would be Na plus, would be +1. The chlorine ions, it would be -1, we would write Cl minus. Right, simple enough. Okay, so hopefully that helps us be able to describe the formation of ions. In our next lesson, we'll talk about what ions do with each other, how they come together and form compounds, how they form ionic compounds. That's why we call them ionic compounds, just because they form from ions. And we'll talk about that in our next lesson. So until then,